changes to the model. So let's create a drawing. So we click on the drawing catalogue, and what we're going to do is we're going to create a typical drawing based on our usual elevations. So we'll click on this here and say okay, let's create drawings. Just close down that library, and we'll say okay, I'd like to have a 3D view, elevation on grid line 1, elevation on grid line A. So that's 3 views on there. Let's have grid line 2 as well, and we'll have some elevations. So we'll have let's say plan on there, plan there. We'll also have a plan on the very base of the building, and we'll say okay, create and open that drawing. And as we open up the drawing, you'll see it's fully completed, so we can add any other kind of information that we wish. So for example, if we click on this particular piece here, we can quite simply say okay, add the part mark, and you'll get the mark of the piece. Again, you can window all areas and say add the part marks. Very easy. Change the properties of the part marks. Like and with anything else in Tekla, it's just an object, so we can click on those, window these ones, modify them so they're all the same. Okay, now that drawing, as we said, will keep itself fully updated to every change in the model. Come out there, save that. My next step is to introduce the diagonal tower members. I'm going to use this component, which you can see I've got set up here. I'm going to just load up one of my typical settings, which have got spacings at 0 for the back marks, 200 between the cross arms. You can see I'm using 100 by 8 sections. I'm going to be using typical cross arm type bracings. So we have to do is select this one here, middle mouse, and we get the bracing set up. I'll now introduce that all the way up the tower. As you can now see, I've introduced the diagonals all the way up that one particular face of the tower itself. If I take a look at the GA drawing again now, you'll see that the drawing has updated itself to include these new sections. So let's take a look at that. And as you can see, this one elevation here has had the cross arm information applied to it. Let's start applying some connections. The first connection I'll apply is the splice connection, which is this connection 175. Again, we set it up to have backing plates and the type of bolt spacings I'm looking for, which is quite simply 3 at 100 both sides, size of bolt being 16. And what we can do is come down to the connection, the part where we want the actual splice, click on the pieces, and we get the splice connection already in there. I'll come across this one now, across here, same at that point, same there, and the same there. These connections, if you're not happy with them or you would like to change them in the future, you can quite simply click on them and change any type of spacing that you want. So for example, if I just want, let's say, 1 row of bolts in that direction, we can change it to be 1 row of bolts. Very simply. I'll now continue to apply those splices all the way up the tower legs. Okay, I've applied those splice connections all the way up the tower legs. If you take a look at the cranked elements as well, you'll notice that the splice connection, it knows it's cranked and will crank the splice connection accordingly. So we've got those connections now all the way up the face of the tower. Okay, we can now start to apply some connections to the actual diagonal members themselves. One of the first connections I'm going to add is actually this cross arm connection here, where these pieces actually intersect each other. I'm going to use a central gusset plate, and what we do is we click on the 4 elements and say connect those 4 together. Again, quite simple. For the diagonal to the arm, I'm going to use the tower 1 diagonal connection. So quite simply, and I'll say okay, let me connect that one to that one. You'll see, click on both points, then it will look at the connection and give you the spacing accordingly. Again, use that one over here, so click on that one to that one. Where there are multiple, I can quite simply click on one piece and select them all in one go. Again, now I'll continue all the way up the tower and apply all the connections. If needed, if we need to use a gusset plate to connect these rather than bolting directly to the legs, we can use any of the gusset plate connections to create gusset plates which connect the diagonals to the main tower legs. Again, simply by clicking on the parts to connect, and you can use that to create even single ones as well. Again, I'll now continue all the way up the tower and put these connections. The face of the tower now has all the relevant connections. Let's see how the drawing's updated itself. So if you take a look at the connections, if we zoom in on the drawing, you'll see all the connections are also shown within the drawing themselves, and we can quite easily create blow-up details or detail view of the connections if required, like so, and add that detail into the drawing. And then of course change the scaling factor of that to suit what we're looking for. So let's make this a scale of 1 to 10, and you have a nice blow-up detail of the connection you've created if required. Once we have one face, we can then array that all the way around the building to create all the other faces. So you can see we've now got all 4 sides of the tower completed, all carrying, as we rotate them, their specific connections around with them at the same point. Of course, from this model now we can produce any kind of information that's what's required. So first of all, let's create some simple reports. What I'll do first of all is create some Excel spreadsheets for the material lists. And that's the first of our Excel spreadsheets. You can see all the profiles listed, lengths, grades, surface areas. Let's do a simple part list now, and that's a list by part. Let's create a barcoding list. So if we come down to the TS lists, piece tag, create from all, we'll show that one as well. There we are, a barcoding list for every piece. Now let's have a bolt list. And there we have a bolt list, 6 diameter bolts, 4.6 grade, length, quantity, with a percentage add-on as well for wastage. We can also create any number of fabrication drawings that's required. Within the system we have templates for many different types and styles of drawings. US, European, UK style, and specific types as well. So if you want to pick them up, so we've got specific types of drawings as well. Let's just create some simple fabrication drawings, style 3, and we'll say create the drawings. So as you can see then, from the model we can also create any number of fabrication drawings that's required, as well as a material list. And of course the GA drawing we created at the very beginning is keeping itself updated, so let's take one more look at that. So you can see our drawing we created at the very beginning, it's always keeping itself up to date. Any revisions are clearly flagged. Any standard reusable components such as tower arms can be made within Tekla and then reused. These can be made yourself by simply placing the elements and then storing away as complete units. So for example, here's one I've got stored away, which is for a typical arm for this structure, and if we click on there you'll see then that is stored away not only with all its member sizes but also all its connections and everything as well. So simply stored away, reusable and fully parametric. Let's add that to all the other sides. That component has now been added all the way around the building. Finally, one last look at the main drawing. So as you can see from the drawing we've created in the very beginning, we now have complete tower drawing. So it's all main fabrication drawings, material listing, linking down to CNC machines, which is what we'll take it in the next chapter.